calcium chloride is a soluble salt. Sorry, not calcium chloride. Magnesium chloride is a soluble salt. Okay, how can you get a pure magnesium chloride crystals? So you want crystals and you want pure. Okay, can be made from magnesium. Okay, so how do you get a salt from the metal? Well, you can get metal plus acid. That will give you salt plus hydrogen gas. All right. Okay, but what happened is, because it's a soluble salt, this is going to be okay. It goes off, but you don't want acid. You don't want leftover acid in there. What you could do is, if you don't want excess acid in here, because you are going to, this is going to be in water. Acid contains water, you see. Aqueous. Aqueous means it contains water. And your salt is soluble in water. So in that water, you do not want any acid to remain. If you don't want any acid to remain, you need acid to be completely used up. If you want acid to be completely used up, you should use excess metal. But then the metal will be insoluble in the water, so you need to filter the excess metal in order to remove it. And then you will have a water solution containing the salt you want with no more acid, because all of it will be used up. Whereas you already filter off the excess metal, which was insoluble, and this will be going off as a gas, effervescence, right? So from that solution alone, what you could do is you could concentrate it, then you set it to crystallize, then you could get the crystals, then you could think about how to get the pure sample of the crystals. Alright, so these are stuff you have covered from your lower secondary actually, but I'm just outlining it in step by step. Yeah, it's also described. It will really help if you outline your things step by step. You could use bullet point. I'm just using numerical bullet point because it will make my point clear. Okay, I hope so. So react magnesium. So they want to start from magnesium, not carbonate. Yeah, they want to start from magnesium. So yes, carbonate plus acid can also react to form salt, H2O, and water. But they want you to start from magnesium. So magnesium is a reactive metal. It's higher in the reactivity series than acid. So you know magnesium can react with acid. Alright, react, maybe I should use the word excess. Alright, I should definitely use the word excess magnesium. React excess magnesium metal with dilute, you could use HCl or H2SO4, it shouldn't matter. Okay, what happened now? Oh, sorry, it does matter. You need HCl because you want the chloride. Okay, I beg your pardon. If you use the sulfur acid, you're gonna get magnesium sulfate, and you don't want that. You want magnesium chloride, so you have to use dilute HCl. That's very important there. So you're gonna get magnesium plus HCl. So I like to write my equation to show that I know the chemistry. But of course, when you write equation and you don't balance it, that defeats the purpose. Okay, so this is magnesium chloride, Mg2 plus Cl minus, is MgCl2, 2 chlorine, only 1 chlorine here, so I need a 2 there. H2, 2 times 1, H2, so 2 hydrogen, this is balanced. All right, because you use excess magnesium, so filter off the insoluble excess unreacted magnesium. So you know filtration, you can remove solid from solution. All right, collect the filtrate. Filtrate is the solution that passes through. Okay, collect the filtrate solution, which would only contains aqueous MgCl2. The aqueous is because there's water there. The acid is completely used up because you use excess metal, whereas the gas already escaped. So all you have is just the salt dissolved in water because it's a soluble salt. Alright, and you already filter the excess unreacted magnesium. Alright, so next bit is you want to do crystallization. So you need to concentrate the filtrate solution by evaporating or heating the filtrate solution, but you don't want to heat it to dryness. You want to heat it until a small amount or a small volume of water or solvent remains. Then you want to allow it to cool. Allow the concentrated solution. So solution, you don't want any solid to appear yet, yeah? Because as soon as a solid appear, then you're not going to get pure crystals anymore. You still want a solution, but you want it to be concentrated. You want it to cool down slowly, and crystals will form. And crystals of MgCl2 will form over time. It could be like a couple of hours or a day or two. Okay, you could then put it in the fridge, obviously, to cool it further, and then filter. Once obtained, you can filter. Once crystals are obtained, you can filter the crystals. Okay, wash with wash with distilled water. You gotta wash the crystals with distilled water to get rid of whatever things that you don't want, I guess. And then dry between filter paper. So you let it dry on the filter paper, then you take it out, and then you dry the crystals again between filter paper. That's how you can get pure crystals of the MgCl2, yeah? Okay. Unless you have been very picky, unless you have struggled a lot, then you should be more prepared when you sit for an O-level paper. Negative ion in sodium oxide is O2 minus. It has gained 2 electrons. The oxygen atom has gained 2 electrons. It's going to have the same configuration as neon, so there will be 2.8. Next bit, you want to get practical details. You want to prepare crystals. You want pure. You want to start from magnesium oxide. Magnesium oxide is insoluble. Okay, so to go from magnesium oxide to magnesium sulfate, you need H2SO4 aqueous. So this is acid. This is basic oxide. Basic oxide reacts with acid to give you neutralization, right? Okay, so first of all, you're gonna react excess magnesium oxide, which is insoluble base, you see, with aqueous H2SO4. Okay, we're talking about practical details here. So because this is very insoluble, right? So what you're gonna do is you might have to stir very hard or warm gently. When you warm the solution, this will help the insoluble MgO to dissolve, and it will push the reaction, will help insoluble MgO to be slightly more soluble. Also, when you warm it, you can help to increase, speed up the reaction a little bit. I think I spelled speed wrongly there. Speed up reaction a little bit, okay? But anyway, the key here is not about speed of reaction, it's about how to prepare this thing, right? Why did we use excess MgO? Because this MgO is very easily removed, and we want all the sulfuric acid to react. Okay, then you filter the excess MgO, which remains insoluble after reaction is complete. So after you filter it, the filtrate is the solution that passes through the filter paper. So the filtrate is concentrated. So what do I mean by concentrated? I mean you try to remove by removing the water solvent with with heat. So you need to heat to remove the water, but you only concentrate it, but not to dryness, because you want to get pure crystal. You do not want impure stuff to come out. So concentrate it. So you get it concentrated. You remove as much water as you can, but at the end of it, you still have a soluble solution, which is concentrated. Okay. Allow concentrated solution to cool slowly and form crystals. So that is crystallization, yeah, and form crystals. And after that, you should once it has fully crystallized, once obtained, filter crystals, dry between filter paper. However, I see this question as not really asking you for dry magnesium sulfate crystal. It's just asking to prepare. So I probably wouldn't include number 5. I can probably just stop there. But the idea is that between forming the crystal and filtering it, you should probably allow a lot of time, because slow cooling will take maybe a day or 2 or even longer to form the crystals, and only then you can filter and dry it further. But I don't think you need that step for this particular question, yeah? Aluminium chloride is a soluble salt, so it dissolves in water, okay? How can you get aluminium chloride crystals? You need crystals, and you start from aluminium. Alright, typically you can think about carbonate plus acid will give you salt plus CO2 plus H2O, right? But then you might not be aware about the solubility of the aluminium carbonate. So what we can also use, which for sure will work, is the metal plus acid. Metal plus acid will give you salt plus water. This will definitely work. The thing is, if I don't use, so this is insoluble in water, this is soluble in water obviously, okay, the aluminum chloride is soluble in water. So if I use excess acid, then in my final solution, I'm going to have salt water and also excess acid, which I cannot separate because soluble in water, the acid also soluble in water. So I need this to be completely used up, because I can separate the metal from water. They don't react. Well, they just told you, right? They don't react. So it will just be insoluble metal in water. Okay. So react excess aluminium with so you want the chloride, so you need aqueous HCl, okay? Then you need to filter off excess insoluble aluminium solid or metal, okay? And then what you want is in the filtrate, because all of it is soluble and all of this is used up already because you use excess metal, right? Yeah. So collect the filtrate, so the thing that passes through, which contains only soluble AlCl3 in water. There's no more acid because the acid is completely used up, and the metal that remains insoluble in water, because of that protective coating earlier, it's just going to be filtered off, okay? So now you want to get the crystals, so you need to concentrate the filtrate. You need to remove the water by evaporating or heating the filtrate. So you don't want it to boil too much, yeah? You just want to evaporate or heat off the filtrate to concentrate. So the word is concentrate. And then leave the concentrated solution So it's still a solution. You don't want the solid to come out because you want crystals. So you need to be concentrated solution to cool down slowly to form crystals. So now that you have your crystals, you should, once crystals form, over time, to form crystals over time, okay, which might be like a night or 2 nights or a couple of days, you know. Once crystals form, filter and wash with distilled water. Then dry between filter paper. Then you can get dry crystals of the pure aluminium chloride. Okay, but this last step might not be necessary because they don't specify dry pure sample, just a pure sample of the crystals. So allowing to crystallize is very important. Yeah. Okay.